Section 2.3, organizing quantitative. Now we're dealing with quantitative data. Qualitative, we saw how we use bar chart or bar graphs, and then we used pie chart or pie graph to organize such a data. Here we are gonna follow almost the same procedure, but we have more tools here to deal with because we are dealing with actual numbers. Let's start with the first one. So we are given 50 randomly selected households. So they question people how many TV sets that they have in their household. And then some said one, some said we don't have a TV, some said up to six. Like really, people have 6 TVs in their household. And so we grouped this data, we collected, we grouped it here, and now we need to organize it. How do we organize such a data? First thing, we can go, because this is what we call a discrete data. It's discrete, so we have numbers, individuals, and then those numbers get repeated, most of them. We can use the number of TVs in the first column, because that's what this is about, and how often, how many people chose that number. So if you look on the table, there's only one person said I have no TV. Only one person. So the frequency is 1. And then how many said 1? There's 16 of them. So if you count them, you're going to find 16 of them. And then 2, there's 14, 3, 12, and so on and so forth. If we take each one, the frequency, the total, this is the total here. Total is 50. If you take 1 divided by 50, so that will give us 0.02. That's what the relative frequency came from. And then if you add all of them up, that should give always 1. So why do we do this? Well, as we did in the previous section, it helps us to sketch graphs. But the graphs we're going to sketch them here are going to be slightly different than the one in the previous section. That's one way to organize. We're going to see later, we're going to come back to this and see how to graph or how to present this data on a graph. Another thing to do is, let's say they give us another data. So this talks about data to maturity for 40 short-term investments. And then we collected this data. We have 70, 64, 99. So we ask kind of like a survey or data from any source. And then we put it in the table here. But notice this data, not so many repetition, if there's any. If you notice, I see 70 twice, 3 times, but then 71, there's probably only 171. 75, maybe there's only 1 or 2. 55, only 1. 53, only 1. So you see the spread of the data. It's not so many repetition here, unlike the previous example. So in this case, what we have to do, we can't just put 70, 71, 72, 73. That will be a really long table. In this case, what we do, we group them. So we use the grouping method to group the data. And to group them, we need to create what we call intervals from somewhere to almost that value, somewhere to almost that value, somewhere to almost. These are called classes. So instead of working with individual data as before, like number of TVs was 1 or 2 or 3, here we go from 2. So over that interval, how many numbers fall within that interval or within that class? How many numbers fall within the next class and next class? It's a much easier way to group them this way. And to do the grouping, there are 2 different ways of grouping. The first one works usually with this kind of data, where there's no decimals involved, just like an integer like this or natural numbers. So what happened here, the person who grouped this, they decided to make the class width to be 10. So it's gonna go, he looked at the smallest data or smallest number in the data. Which one is the smallest? I see 36, 39, 38. So 36 is the smallest. So it would be convenient to start at 30 and move on to 30 to 39. Okay, so 30 to 39, as you can see in the table below. So from 30 to 39, then 40 to 49, 50 to 59, and so on and so forth. We went all the way up to 99 because that's the largest value I see in the data, in the given table. Now notice something here. The class width, I said it's 10. So the class width can be found by taking the first data in the second row minus the first one in the first row. That's 10. Or for the next one is 50 minus 40, 60 minus 50, and so on and so forth. So 30 is the smallest value in that class. So that's the lowest value. And 40 is the lowest value for the next class, and so on and so forth. If we look at the data, back in the data, how many in the 30 to 39? Well, I see 36, I see 38, I see 39. There's only 3 of them. That's why the tally shows 3 and the frequency 3. And then we did it the same for the next one and next one all the way down. So there's a total of 40 values. If we take 3 that I just circled here, this 3, and divide it by 40, that gives us 0.075. That's where the relative frequency came from. And same thing with the rest of them. To check, make sure you did not make any mistake, add all the frequencies, and the total should always add up to 1 for relative frequencies. Now, here, this is called limit grouping. So this method is called limit grouping. And so they talk about the lower class limit. This is the smallest value that could go in a class, in each class, like 30, 40, 50, 60. The upper class limit, that's the largest value that goes in each class. In this case, 39, 49, 59, 69, and so on and so forth. The class width is the difference between the lower limit of a class and the lower limit of the next higher class, as we did 40 minus 30. So here it's 10, which is 40 minus 30, or 50 minus 40, 60 minus 50, and so on and so forth. Class mark, we're not going to use it that much, but it's basically the average of the 2 class limits. So for the first one would be 30 plus 39 divided by 2, and 40 plus 49 divided by 2. That's one method. Now what happened is, what about if the data in the table, this table here, was in decimals? Then that would cause a problem, because what about if they give me one of the data to be 39.7 or something? So let's say we have 39.7. Where is that going to fall in? Notice in this table here, it goes from 30 to 39, and the other one 40 to 40. So it's kind of like in between these 2 classes. So that's why what we do here is we need to create different kind of classes to be able to include all the decimals, no matter what they are. And to do so, we start at the same point, 30, but we're not going to go to 39. We're going to go all the way, you can say, to 39.999, let's say, or 39.9999. Doesn't matter how many nines you put in there. But to make it easier for us, we're going to go from 30 to, so we're going to do it in a way, we're going to go from 30 to almost 40, okay? All the way up to less than 40. So when you say less than 40 or lower than 40, means you're including any number, regardless, less than 40. Okay, from 30 to really less than 40. So less than 40 or lower than 40. Same thing, the next one will be 40 to less than 50. Next one, 50 to less than 60. And this list goes on and on. So this is called cut point grouping. Cut point grouping. So if we look at an example, let's see, do we have an example here? No example. So we don't have an example, but that's how it works. We go 30 to less than 40, 50 to less than 40 to less than 50, 50 to less than 60, or lower than or smaller than, anything you like to use. Now here, this is a table to summarize where do we use each method. So the first method, the single value grouping, this is used in discrete data. That's when you have so many repetition in the given data. That's when we go say, okay, how many people said they have 0 TV? How many said they own 1 TV? How many own 3 TVs? And so on and so forth. How for the limit group, this is data when we have whole numbers. Whole numbers, that's when we have no decimals. Whole numbers, they start from 0, 0, 1, 2, 3. You know, the whole number starts 0, 1, 2, all the way, no decimals. And then the next one, the cut point grouping, that's when we have a continuous data. That's involving decimals. So it doesn't stop, it's not a whole number, it's decimals. That's where we use the cut point grouping. Now, one question people might ask, how many classes do I have to have? Like here in this case, they start 30 to 40. Why they made it 10? Why they made the class with 10? Well, one thing to do here is, if you take the highest value in the data, which was 99, and then subtract 30, the lowest value. Was that the lowest value? No, the lowest value was 36. That gives us 63. And now you decide on how many classes you like to have. Here they decide to have 7 classes. So this means you take this divided by 7, and that's 9. And then that's where, when they started with 30, they went 9 steps up, so they got to 39. So they went from 30, 9 steps, 39. Then 40, 9 steps, 49. 50, 9 steps, 59, and so on and so forth. That's where that came from. Good to know. And now we introduce a way to represent this, regardless if it's single value group method, limit grouping, or cut point grouping. All work the same way. At the end, we're going to have a frequency. At the end, we're going to have frequency to each one of them, and relative frequency. So we're going to take these tables that we constructed earlier, such as this table here, and plot those on what we call histogram. Histogram is similar to the bar graphs we did earlier. The difference is that the bars should touch each other here. So histogram is just a display. It's used to display quantitative data. So the histogram is used to present it this way. So on the horizontal axis, we put whatever data we're talking about. On the vertical axis, we put the relative frequency or percents in that case, or if you like to use frequency, it's fine. So let's see how to construct a frequency, relative frequency histogram, or histograms in general. So if you look back at the TV, people answered from 0 to 6 TVs. Some people said I have no TV, like 0. Some said up to 6 TVs in their household. So that goes on the horizontal axis. You start labeling them 0, 1, 2, 3, 4, 5, 6. And then the frequency, or relative frequency, goes on the vertical axis. And that's what happened here. The number of TVs went here from 0 to 6, and the frequency goes there. So if you look back on the table for the TVs, the frequency, the highest frequency I see is 16, and the lowest is 1. So it would be convenient to go up from 1 to 16 on the vertical axis. So we went by increment of 2, make sure 1 is there. So 0, 2, 4, 6, all the way to 16. So the first one was 1. If you remember, only one person said have no TV. So that's why the blue bar went up to 1. The next one was 16. Then the next one 14, and so on and so forth. Notice something here. The bars they must have the same width first, and they must touch each other. And then for the relative frequency, we just put the decimal form of it. And this decimal form came also from the table itself. So you can present it either using frequency or relative frequency. Now the color doesn't matter. It doesn't matter if it's a blue color or orange color. They're just trying to distinguish between them, that one of them goes for frequency and one for relative frequency. And the same thing applies This is for the discrete data about the TV count, and the same thing applies for other examples we presented up there. The one about the investment, the short-term investment. So here it talks about the days to maturity. So remember how they give us 70, they give us 80, 90, 99, so here we present them by tens. You can decide. Some people might go by fives, which will make it wider. By 10 should be good. Don't go by like 50, for example, like 0, 50, 100. Otherwise, you can't have any bars. But what we do here is, remember how the interval we started with 30 to 39 for the first one, 40 to 49, and this went all the way to 1999. So then on the horizontal axis, we put the 30 to 40, then 40, 50, 50, 60, and so on and so forth. When it comes to constructing the histograms, those bars we draw here, we will go from 30 to 40. Like there's no such, as you can see here at that point. This is just 30 to 40. It doesn't matter if we do it this way or not, or because you want the bars to touch each other, so it has to be a histogram, touch each other, same width. So from 30 to 39, there were 3 of them. From 40 to 49, I believe it was 1. So the height of the bar tells you the frequency, how often this happened, how often this occurred. So that's the frequency we have. And we do it the same way for relative frequency. The only difference is just the vertical bars are different. And then, as I said, everyone might look at it slightly different, but at the end, the shape will look the same. The shape must look exactly the same way. In bar graphs, we could arrange them in any way we like. Remember, we put Republicans, Democratic, and then other. You could put Republicans, Democratic, other, or you can put other Republican, Democratic. It doesn't matter how. But here it must go in order. It must go from least to largest. Least to largest. So this is about the other example. And this is just another random example talks about the cut point grouping for the weight. So, weight, you don't have to be always like 130 pounds or exactly 200 pounds. You can be like 200.7 pounds or 199.6 pounds. That's where this cut point grouping works. We don't have the table up there, but this is basically representing the weight of a group of people that were questioned, like about their weight. And then, or like probably you see this when you go to a doctor or something, they can give you your weight relative to other people who visited the same office with the same age, let's say. They tell you how many. Like they show you, oh, you fall here in this column, or you fall in that column. One thing I want to comment on here is that the construction here exactly goes the same way as the previous example. Exactly the same way. The other thing is the numbers, make sure in histogram these numbers go in order. Although in this area there was nobody had this weight between 220 to 260. No one said like my weight is between 220 and 260 pounds. But maybe someone said that his or her weight falls between 260 and 280. And that's what the last bar is for. Although there's nothing in between 220 and 260, we still have to include it in our sketch. And then the same thing happens here, and the only difference between these two graphs, one is frequency, one relative frequency. Next plot to organize it is called dot plot. Dot plot is very easy, the easiest plot maybe you can deal with. So they give you a set of data. Let's say here, just to explain it, let's say 2, 4, 1, 2, 3, 2 again, 3, 3, 1. So let's say they give me a simple data like this. You draw a horizontal line. You see the numbers range from 1 to 4. 1, 2, 3, 4. Even if there's a number missing, let's say 6. So there's no 5, but we still have to put the 5 and the 6. 2, I see 2, so we put a dot on the top of 2. 4, we put a dot on top of 4. 1, there's a dot here. 2 again, we put another dot. 3 on the 1 dot on the 3. The 2, another dot on the 2. Another 3, another 3, and then 1 again, and 6 for the last one. So that's called dot plot. Very easy plot to use. And then this is an example. Here the numbers are big, like 210, 2 something, but you look at the smallest number. What's the smallest number I see here? 209, 208, I see 197, 197. So then here you go up, you know, from 190. You don't have to start at 190, you can start 195. This is 195, 196, 197. That's why there's a dot there. Then the next one is, there's no 198, but there's 199. I put a dot on 199, another 199. And then so you look at the largest value you see here. Maybe 224, I see 224. So you're gonna go all the way up at least to 224. You don't have to go up to 230, but 224. And then, so you start labeling. 210 falls in here. 219 falls in here. 214 falls in 210, 11, 12, 13, 14 falls in here, and then so on and so forth until you label all of them. That's called dot plot. Now stem and leaf plot. Stem and leaf is that they give you, usually it works with the 2-digit number and higher, like 3-digit, 4-digit. If it's 2-digit number, the way it works, let's say they give us 23, 11, 39, 33, 47, 61, 18, 19, 18 again, 31, and 22. Let's say they give us as easy data like this. So the way we construct stem and leaf, in the stem we put the tens digit, and the leaf the ones digit, tens and ones. So this is tens digit, this is the ones or the units digit. So what's the smallest number? I see 11, so there's a 1 here. We go 2, 3, 4, 5, and the max I see is 6. So 23, how do you present it? 23, like that. 11, 1, 1. 39, 33, so there's a comma here. We put a comma, so now this reads 39, 33, 47, 61, 18, 19, 18, 31, 22, right? Nothing in the 50s, but we still included there. We still included. Now, what about if it's a 3-digit number? If it's a 3-digit number, then let's say we have 231. This goes in the stem, and that goes in the leaf. Okay, that goes in the leaf. And I'll show an example here. So this one here is similar example to the one I just presented. The smallest value falls in the 30s in the table, and then the maximum is in the 90s. Okay, in the 90s. So as you can see, this is the same example we had before. It's about the investment. So I see 39 or 38. Maybe there is 36, right? 39. So the maximum is 99. So that's why they presented in this column 3, 4, 5, 6, 7, 8, 9. And then they start going over this. 70, so 70. 64, 64. And then the next one. And then what they did here, they notice these numbers don't have to be in order, but what they did, they just arranged them. 6, 8, 9, 7 stays the same. Here the smallest is 0, then 1, 1, 3, 5, 5, 6, 7, and so on and so forth. You don't have to arrange them this way. You can keep it. The stems and leaves, they can stay the same. You can keep the numbers here in that order. But here what they did, they actually organized them. You don't have to. The next one talks about a 3-digit number. as I said, the smallest number you see here in this small table is 197. So they start with 19 and then went 20, 21, 22. So 197, and then we have 199, 199 again. Okay, these are in the 19s. In the 20s, we have 209, 208. And now, when we want to put it on the graph, notice this table here that was presented, there's a typo with this table here. It shouldn't be, because you don't see the 197 in the stem and leaf plot. And I'm gonna write down the actual table, the correct table for this. One more row. So this is supposed to be 210, 217, 208, 215, 202, 209, 207, 210, 221, 218, 212, 210, 210, 213, 200, 208, 218, 214. So now what we have is there are several ways to present the stem and leaf plot. So for this case, I'm going to show two things, and you will see what explain the difference between them. So when we started with 199, that's the smallest value I see in the table. That's where this went here. Now when we start with the 20s, the 200s, there's 201, 202 first, so 22, 200, there's a 0, 208, there's an 8, 207, and so on and so forth. So there's a 3, there's an 8, another 8, there's a 9. So these are in the 20s. And then what they did, they just arranged them. So they wrote the same one. The smallest one is 0, then 2, then 3, then 7, 8, another 8, and 9. So that's where this came from. And then the same thing for 21 and 22. Now, for later sections, you will see why we're doing this. We can do a 2-line per stem. Means we can take the 19. Notice how 19, we did 2 19s, 2 20s, 2 21, 2 22. And how we choose the numbers to each one of them. The first number can go from 0 to 4 or 0 to 4. So on the first number, anything that between 0 to 4 goes in here, and anything from 5 to 9 goes in there. And since it was 199, that's why we put it there. For the 20s, for example, where did this come from? Well, we start 20, 2 of them. 0 goes in here, the 2, the 3, and now anything after 4, like 7, goes in here, 8 goes in here, another 8, and 9. That's where this table or this came from. Basically, think about it as we wanted to spread it even more. Okay, spread it more. And then later on, you will see why we do this. It's just what we call the shape of the distribution. It will help us more if we have it written in this form.